Think about how software developers work. They do not rewrite their code from scratch every time they need a new feature. They build libraries of reusable components, tested, optimized, ready to deploy, and assemble new solutions by combining what already works. The result is faster development, more consistent quality, and systems that scale far beyond what any single piece of code could achieve alone. What if you applied that exact same thinking to your prompts? That is precisely what this video is about. We are moving from individual, one-off prompts, no matter how well engineered, into something fundamentally more powerful, a modular prompt system. A library of reusable, combinable components that you can mix, match, and deploy across every task you face, without starting from scratch each time. In this video, you will learn the core components of a modular prompt architecture, master the module framework that ties it all together, and discover how variable-driven template systems give you flexibility and consistency at the same time. By the end, you will have the blueprint for a personal prompt library that makes every future task faster, more consistent, and more powerful than anything you have built so far. Let's get into it. Most people build prompts the same way every time. They start with a blank page, think through what they need, write something, test it, refine it, and eventually get to something that works. Then, the next time a similar task comes up, they do the whole thing again from scratch. This approach has a hidden cost that most people never quantify. Every prompt built from zero is time spent reinventing a wheel that already exists somewhere in your previous work. Every inconsistency between similar prompts creates inconsistent output. And every refinement you make to one prompt stays locked in that one prompt, never benefiting the dozens of related prompts you will write in the future. Modular prompting solves all three of these problems simultaneously. It treats your prompts like a professional toolkit, where each tool is tested, refined, and ready to use. And the best solutions emerge from assembling the right tools in the right combination for each job. The benefits are concrete and significant. First, consistency. When the same modules are used across similar tasks, the outputs share a reliable baseline of quality and structure. Second, efficiency. Less time rewriting prompts from scratch means more time doing the actual work. Third, optimization. When you improve a module, every prompt that uses that module immediately benefits. Fourth, collaboration. Modular systems are easy to share with team members because each component is clearly defined and independently understandable. And fifth, scalability. Complex tasks become manageable when you can decompose them into proven components, rather than trying to engineer everything at once. The shift from individual prompts to a modular system is one of the most significant upgrades an intermediate prompt engineer can make. Let's build yours. A well-built modular prompt system has 5 core component types. Think of these as the categories in your toolkit. Each one serves a distinct function, and they combine to cover virtually any task you encounter. Component 1, base templates. These are the foundation structures for your most common task types, the skeleton that everything else attaches to. A base template for content creation looks different from one for business analysis, but both provide the reliable starting structure that ensures nothing critical is missed. Base templates are your most used components. They should be simple, clean, and adaptable. Component 2, specialized modules. These are task-specific components that you plug into your base templates when a particular task demands it. An analysis module, a bias mitigation module, an error resistance module, a creative brief module. Each one is a self-contained block of instructions that addresses a specific need. Specialized modules are where your most refined engineering lives. Component 3, format libraries. These are reusable output specifications. Your table formats, your hierarchical structures, your custom delimiter systems. Instead of rewriting your format specifications for every prompt, you maintain a library of proven format blocks that you can drop in wherever they are needed. Component 4, persona definitions. These are your fully engineered voice framework personas, the specialist characters you have already built and tested. Rather than constructing a persona from scratch each time, You maintain a library of ready-to-deploy experts that you can call on for different task types. Component 5, instruction sets. These are reusable process guidelines, the step-by-step analytical protocols, the self-verification sequences, the chain of thought structures. When a particular process works reliably, you codify it as a reusable instruction set rather than rebuilding it each time. Here is what a complete base template looks like when all 5 component types come together. Insert persona module, insert task description, insert process module, insert constraint module, insert format module. That structure is your assembly point, where you slot the right module into each position for the specific task at hand. The module framework gives you a complete operating system for building, managing, and continuously improving your modular prompt library. Each letter represents one principle of effective modular design. M, mix and match components strategically. Not every combination of modules will work well together. The art of modular prompting is knowing which components complement each other and which create conflicts. An analytical process module pairs naturally with a data-driven persona. A creative brief module pairs naturally with a conversational format specification. Strategic mixing requires understanding how each module functions and what it needs from the other components around it. O, optimize each module independently. One of the greatest advantages of modular design is that you can improve individual components without rebuilding the entire system. When your analysis module consistently produces shallow conclusions, you refine the analysis module, and every prompt that uses it immediately improves. This independent optimization compounds over time into a system that gets progressively better with every iteration. D, document module purposes and interactions. A modular system without documentation is just a collection of disconnected prompts. Document what each module does, when to use it, what it works best with, and any known limitations or edge cases. This documentation is what transforms a personal collection into a professional system, one that others can learn and use, and that you can still navigate reliably 6 months from now. U, update modules as you learn what works. Every time you run a prompt and get exceptional results, ask yourself which module or combination of modules produced that result, and update your library accordingly. Every time a prompt falls short, identify which component failed and refine it. Your modular system should be a living, evolving library, not a static collection. L, link modules coherently with clear interfaces. The point where modules connect is where most modular systems break down. Clear interfaces, consistent naming conventions, predictable handoff points, explicit signals about what each module expects from the ones around it, ensure that your components work together smoothly rather than creating friction or contradiction. E, evaluate the performance of different combinations. Track which module combinations produce the best results for which task types. Over time, you will develop a clear sense of your highest performing combinations, the go-to assemblies for your most common challenges. These become your signature prompt configurations. Base templates and reusable modules give you consistency. Variable-driven systems give you flexibility. Together, they give you a system that is both reliably structured and infinitely adaptable. A variable-driven template is a prompt with clearly marked placeholder slots, variables that you fill in for each specific use case, while the underlying structure remains constant. The variables are the parts that change. The architecture is the part that never does. There are 4 types of variables worth building into your templates. Content variables are the specific information that changes from task to task, things like topic, industry, audience, and company name. Parameter variables are adjustable settings that tune the output, things like detail level, formality, and creativity. Format variables are structure modifications, output type, section count, and length. And process variables are methodology adjustments, framework, approach, and priority. Here is what a variable-driven template looks like in practice. Document type, template, topic. You are a expertise level role with expertise level role with expertise level role with expertise level role. Create a document type about topic for audience with the following specifications. Purpose, purpose. Key points to cover. Key B, tone, and the detail level should be detail length. Length, approximately length words. Structure the document with a Section 1 section, a Section 2 section, and a Section 3 section. Additional requirements. Output format. Output format requirements. DHTVI section, and then these out requirements, specials next one. Output format. DHTVI section, and then these out requirements, specials next one. Output format. Use the special and requirements. DHTVI section, and then these out requirements, specials next one. Additional requirements. Specialments. Output format. Output format. That single template, with its variables filled in, can produce a technical white paper, a client proposal, a training guide, a marketing brief, or a business report, simply by swapping the values. The architecture stays constant. The content adapts completely. The template framework gives you 8 principles for building variable systems that work reliably. Tag variables consistently using curly brackets so they are always easy to identify. Explain usage with clear documentation so anyone can fill the template correctly. Modularize components so sections can be mixed and matched. Prioritize common customizations as variables. The things you change most often should be the easiest to adjust. Limit variables to essential changes. Not everything needs to be a variable. Avoid over-parameterization, because too many variables create complexity without adding value. Test with diverse inputs to verify the template handles different scenarios gracefully. And evolve based on usage patterns. The variables that never get changed are candidates for removal. The adjustments you always make manually are candidates for becoming new variables. Here is your 3-part practical challenge for this video. For the first part, identify 3 to 5 common task types in your work. The things you use AI for most frequently and most consistently. For each one, create a base template using the 5-component structure: persona, task, process, constraints, and format. Then develop at least one specialized module for each task type, a component that addresses the specific demands of that particular kind of work. For the second part, take one of your most frequently used prompts, one you have refined over time and know works well, and convert it into a variable-driven template. Identify every element that changes from use to use and turn those elements into clearly tagged variables. Then create a small reference library of variable values for your most common scenarios, so filling in the template takes seconds rather than minutes. For the third part, combine your components into a complete modular system for one high-priority task area. Test at least 3 different module combinations, document which works best and why, and create a simple decision guide for yourself, a reference that tells you which modules to assemble for which kinds of tasks. What you are building through this exercise is not just a collection of prompts. It is a professional prompt engineering infrastructure, one that compounds in value with every task you complete, every module you refine, and every new combination you discover. Let's bring this together. In this video, you learned the 5 core components of a modular prompt system: base templates, specialized modules, format libraries, persona definitions, and instruction sets. You mastered the module framework across all 6 principles: mix, optimize, document, update, link, and evaluate, and understand how each principle contributes to a system that grows more powerful over time. And you now have the template framework for building variable-driven systems that are simultaneously consistent in structure and infinitely flexible in content. You are no longer building individual prompts. You are building a professional toolkit that makes every future task faster, more consistent, and more powerful than the one before it. In the final video, video 10, we bring everything together. You will build your own signature prompt engineering framework, learn the meta and improve systems for continuous optimization, and leave this course with a complete, personalized system that reflects your specific needs, workflow, and goals. It is the capstone of everything you have built across this entire course. See you in video 10.